Avian respiration is thought to be more efficient than mammalian respiration because it is believed that the airflow in the lung is a one-way flow opposite to the flow of blood. There is little evidence for this, and in theory it means that 2 respiratory cycles would be needed to ventilate the lungs once, which is not efficient. This film is an alternative view and demonstrates the avian respiratory cycle as a 2-way airflow which ventilates the lungs twice in each respiratory cycle. The lungs are relatively small and do not expand and contract. Air enters the lung via the bronchus, which subdivides into several secondary bronchi and many tertiary bronchi. These emerge from the lungs into the air sacs, which do expand and contract. There are normally 9 of the thin-walled air sacs, one of which connects to both lungs. The air sacs are tucked among the viscera and do not take part in gas exchange, but are connected with some pneumatized bones to help with cooling the musculature and the internal organs. Although all of the air sacs are connected as part of a network through the lung, that does not mean that air flows from one air sac to another, because all of the air sacs are at the same pressure at any particular time. To maximize the gas exchange in bird lungs, the air in the lungs is kept moving. During inhalation, as the rib cage expands, all of the air sacs expand, air is drawn in through the lung and into the air sacs. As the rib cage contracts during exhalation, the air sacs contract, air is forced out through the lung, through the bronchus and out of the trachea. This means that in each respiratory cycle the lungs are twice flooded by moving air and no stagnant air is left in the lungs. It is this double ventilation during each respiratory cycle that makes bird respiration more efficient than mammalian respiration and 4 times more efficient than the theoretical one-way airflow.